So what I thought I'd do, normally I have slides and I write jokes and I try to make whatever the talk, whatever sort of engineering talk as entertaining as possible. But what I thought I would do instead is try something different, do a little bit more of improvisation. The thing is, I could talk about something that I'm really interested in, and that may just bore you all to death. And continuous delivery is such a large topic that, and I have so much energy around it, I could absolutely, there's no doubt in my mind, talk for 6 hours. And that would suck for all of you, it would be awesome for me. Arguably, you're saving both my wife and my coworkers from going through that by giving me an opportunity to talk. But what I thought I'd do is get a whiteboard, because I like to draw, and maybe just it's gonna like not entirely structureless, but maybe get some skeleton sort of structure, and then see how it goes from there. I don't exactly, I know what words I want to write down on the whiteboard, but I don't know what we should do after that. So we're going to make it up. Let's see, 4 colors. This will work, 4 words. All right, so I got these 4 words up here: anticipation, monitoring, response, and learning. So what I want everybody to do is make like a venture capitalist and interrupt me at any moment. Raise your hands. I don't think we should do this, talk about these topics, and then not have people like wait until the end of, Mr. John, what's your, I've got a question about this thing that you said 45 minutes ago. I think that no matter how we describe continuous delivery, continuous deployment, continuous integration, no matter how we describe it, these bits are in play. For most of who doesn't work on a property on the internet? Does anybody write software that's not delivered via the webs? All right, and you're going like this. I want to hear about that.
Well, it's all over the place, really. I write a language for FactSet. They do most of the technologies delivered through the internet, but it's not on the web, so to speak. All right.
What about you?
Just internal corporate deployment systems.
Okay.
Almost as if it was on the web, but not actually facing public, I guess.
But do they get delivered to a browser?
No.
Do they get delivered to a phone?
No.
Do they get delivered to a printer?
Not on that star. Fax machine, actually.
Okay.
Right. It's basically just deployment systems. Right?
Okay.
Serving the developers.
Gotcha. And who else? Somebody in the back?
Yeah.
What do you do?
I work on a math library corporate that goes on to 450 different.
Okay, so shipped software. Okay. Anybody else? All right. Yeah.
Well, you know what I work on.
Yeah, you work on I'm chef. But still, right? At least in a lot of the cases, well, I hope this is going to be interesting for you. If not, and I bore you, then you can leave and I won't feel a bit bad. I'm still going to talk for a long time by myself anyway. What these are, there is a somewhat of a the way I like to view software development from from brain cells to production is through this lens. It offers like a really, I don't know, good mental map for me. So in any definition of continuous delivery, and when we say continuous delivery, if I say continuous deployment, nobody but Jez Humble's going to be all unglued about it, so just go with it. Go with it. What are some of the, what could we say is a belief about continuous deployment? Anybody?
It happens often.
It happens often, so about rates, what else?
It's very modern.
It's very modern. That's a really good. So it's modern and it happens often. Anybody else?
Short cycles?
What's that?
Short cycles?
Short cycles. Almost again somewhat about frequency as well. Possibly size, right?
Fully automated.
Fully automated. All right, we're gonna have a blast with that one.
It's good for bug fixing.
It's good for bug fixing.
Highly tested.
It's highly tested. This is going to be awesome.
Nice.
Ideally highly tested.
Yeah. Oh, let's talk about ideals. All right. All right. Let's just start right here. Let's put aside. I think you're right that it's modern. But let's set that aside for a second, because we'll want to come back to that a little bit later. Actually, that's a good sort of anchor for that. So often and short, largely what we hear is that continuous deployment sort of embraces the idea of small but frequent changes, right? What's the idea there? The idea there is that a small change is a change whose surface area is small. I mean, the surface area of either code. To be fair, you could also say you could apply it to hardware as well. What does this mean? It means that in diagnosis, when looking at something's wrong, after something is in production, if you only deployed 5 lines, then you only will have to look at 5 lines, right? That's kind of the notion. Set aside that that's completely false, and there's no such thing as immutability. But especially when it comes to the pretty trivial to build something that has more complexity than or indeterminism than 5 lines. But let's just say it's a good start, and it's a reasonable place to start. Okay, so we'll take our five lines, and we'll take what should we do with that? Let's take testing. Okay. Why would we test something? Come back with me to sort of first principles here. Why would we test these 5 lines?
To know if they work.
To know if they work. Right. Exactly. What's that?
See if they break other things.
See if they break other things. That's a really good point. Probably one that we spend not enough time recognizing deliberately and explicitly, but that's almost certainly the thing that's most concerning, at least to those folks who sort of attempt this continuous deployment business. If you've ever written 5 lines and the 5 lines have no bug at all, but may trigger a latent bug somewhere else, that sort of speaks to the point. So why would we want to test? We want to see if they work. What are the various ways that we can confirm that something works?
Unit tests.
A unit test.
Integration tests.
Integration test.
Requirements to start with.
Requirements to start with. So, I think what we're talking about, and where is he? There he is. I think what we're talking about here is that testing might be, if we consider that testing is a way that we gain confidence that this that this thing that we wrote is going to do what we expect. So in that case, it's about expectations. Gathering confidence about your expectations, as it turns out, it doesn't have to be prescriptive. And we do this every day. We take the train. The trains are never going to ride on time. We fix our phone's autocorrect. We course correct in ways that give us confidence in all of the actions that we do, and writing software is no exception. The thing is we never notice those things because they come like muscle memory. And we generally notice them when they don't work for us instead of when they do work for us. Let me ask you this. What's the possibility of not testing any of those 5 lines and it being okay? Possible, right? Who thinks it's impossible? So why would we, again, does testing code take more time than not testing the code?
Yes.
Right. And time is money. So if there's there's a non-zero chance that it's not going to break anything and it's not going to surprise us, then why would we test it? It's because we believe that there's a larger likelihood that it will break than not, right? Otherwise, we would test it now. How many folks would run an entire full battery of suites for an HTML comment? Why? We've changed bytes, we've changed bits. Let me ask you this. RM minus RF dot/star versus star. Right? 2 characters. You can do a huge amount of surprise by 2 characters. But if we laugh about throwing a full battery of tests at an HTML comment, which could be really long, it could be a lot of characters, right? It just means that we bring our experience to the table, and so that means that history matters. So there is no science here. We can talk about statistics, that's a different talk. But what we are talking about is confidence. And once we say that we can gain confidence in ways other than testing, then what we can do is then we can lay off the part about code coverage. We can lay off the idea that confidence can only come from following software development practices that were written in a book maybe a long time ago. A long time ago when we shipped software, except for the guy in the back, so where we shipped software where the cost of deploying it was so high that the emphasis was on testing. So, confidence. One of the things that, tests, I haven't argued against tests. I just want to investigate and sort of put it on the operating table and pull it apart for a little bit so that we can investigate our own assumptions when it comes to how much confidence we place in a test. What might be another way to gain confidence besides a test?
Experience?
Experience, but let's operationalize that.
Monitoring.
What's that? Monitoring, right. Monitoring. Knowing, and monitoring itself is a really super rich topic. So monitoring, that's a decent one. What do we mean by that?
Look at how the software works, behaves, and
Right. So, but then we're faced with other decisions, right? What to look for, right? You can't just say, oh, well, we monitored it.
follow the specs.
What's that?
Follow the specs.
Follow the specs. The specs that were written by the person who hasn't seen the software yet. So we'll follow those. Certainly, we shouldn't ignore them. But what else should we do? One, we could say that we could. Do you have a suggestion?
Kind of split the difference, like dog food kind of thing, pre-release internals.
Yeah, exactly. This is another one. You said dog fooding, internal usage. This is something we do at Etsy quite a lot. But again, we could do that without monitoring things. What I want to bring up is that while monitoring is a very reasonable thing, you could say, and I would say maybe, I think Noah Sussman has said as such as well, is that like it's kind of like testing, but after. But again, it is a confidence-inspiring stuff. Just like tests, you have to make a decision. I'm going to test for divide by zero. I'm going to test for these. I'm going to test for these conditions. All of these conditions that I have thought of. How many times have we written a test? A lot of tests, and it just so happened that the way it broke was in the way that I didn't test for. Same thing with monitoring. We could say monitor all the things. This becomes a combinatorial problem because we could look at what's a common way of looking. We could look at time series graph. We get a new piece of code. We can graph a bunch of things. We graph the server time, graph the application code execution, graph the memory footprint. What else? We could graph IP requests, Ethernet frames, used CPU, heap CPU, user CPU, system CPU, DNS requests, database queries, kernel system calls. Which one? Any more? I think we...
Interrupts.
Interrupts, right. Open file descriptors, good thing. Yeah, right? Lots of stuff. Packet payloads, header sizes, context switches, paging, swapping, all of this stuff. Awesome. What's the chance that we have an ability to put more monitors in place than we can pay attention to? So now, just like writing a test, we've got some decisions to make. And there are downsides. We believe that there's upsides. And it's actually it's a reasonable suggestion to say monitor. The second thing that you say is, all right, I'm going to monitor. What should I monitor? Should I monitor the execution of particular code blocks? Right? We wrote this thing probably, 4 years ago, called StatsD. Pretty awesome, kind of democratized metrics collection at Etsy, and essentially boils down to within your application, you get a graph for the cost of writing one line of code, and that line is not that long. You'll almost certainly spend more keystrokes if you're an Emacs user. So what does that mean? It means that as of yesterday, we have 411,000 time series graphs. So you could say, we want to gain a lot of visibility. This is going to give us confidence, and you wouldn't be wrong about that. There's a downside. The downside is that just by having as many graphs, we can feel super confident that we got it all covered. Now, I think that we could probably write more graphs than most people. What should we do with those graphs? Should we stare at them? We could make a dashboard. But what if I have to go to lunch? So we make an alert, right? So if something's wrong, or something's weird or anomalous, then we'll have it page a human. That's what we do. Okay, another decision. What's the threshold? Well, what's the relationship between a false positive and a false negative? How often will I get a page and say, this is probably not that big of a deal, and then put it down? In which case, well, let me ask you this. How many folks drive? You have a car. Okay. Keep your hand up if you have an alarm on your car. Okay. Put your hand up if you've heard a car alarm in the last week. Okay. Surprising that you even noticed the alarm went off. It's a weird thing, right? Most people don't pay attention to car alarms, but they do to smoke alarms. So what does this tell us about alerts? It means that we want to know when things are broken or unexpected in the exact same way as tests. But the thing is it requires us to know what to look for. And our imagination is going to be limited because, let me ask another question. How many of you have an internal corporate wiki? All right, awesome. How many people have gone to a wiki page in your corporate wiki where you know immediately that you're looking at outdated information? Okay. It was because the person who wrote, could have been you, I've certainly written them, the person who wrote the wiki page filled it with information that made sense to them at the time. Just like the person who wrote a test, just like the person who put an alert in, just like the person who drew a graph. It made sense to them at the time, probably because they were prompted. They good intentions. I better write this down so somebody else could take a look at this. I better write this test so I'll know if it breaks. I better write this graph so I'll know if or this alert so I know it's doing what I expect. But the thing is over time, with continuous deployment, we just heard it's often. It's small and frequent. I don't know Daniel, how many times did Etsy deploy the web stack today? 30 something, whatever, as long as it's more than 3. So hold on. So I'm going to encode my knowledge, my assumptions, and my expectations about what the future should look like, good or bad, in alerts and graphs and wiki pages and tests. Which isn't to say there are almost certainly wiki pages that are still very relevant. Maybe half of them, maybe all of them. But the fact that they can drift, just like tests, just like metrics, just like alerts, means that we have to continually keep our imagination alive, right? And no one person is going to be able to keep an imagination engaged and asking the questions and sort of remaining sensitive to failure, paying attention to whether the rules, because what we're already talking about are rules and procedures, whether those assumptions are still valid tomorrow or 3 months from now or 6 months from now. I don't know how to use a calendar on my phone. Forget about keeping all of that in my head. So what does that mean? That means that we end up working in teams. How many people here are solely, meaning zero, not titles or anything like that, are the only person in their company who is responsible for writing tests? Awesome. I expected at least one person to say that. And that's good. I'd say that maybe a couple of years ago that we would see some hands. That's good because you need to have, this is the reason why we have code review, right? Many eyes, bug shallow. Do you?
No, but if you're accelerating the pace of delivery, the overhead of communication forces you to abandon quality assurance because it takes too long. That's why you need quality assurance integrated into the development.
Sure, this is absolutely fine, and I fully agree. Although I might say that the channels of communication move from what we might think of as sort of inter-office and inter-human communication, and instead we communicate through things like, Jenkins results and code reviews and comments and alerts, right? So what does this mean? It means that if the well-intentioned and very smart tester, monitor person puts all of their knowledge, encodes their knowledge in how the code's supposed to work, but then if we're accepting the part where it's probably faulty and at least foolish to believe that the alerts and the tests written 2 weeks ago are going to be absolutely the same in relevance as they are today, then how can we talk about ideals then? When something breaks, we could say, oh, well, there wasn't a test for it. Well, this happens. This happens a decent amount. Let me tell a quick story. It's a really good story, but it's pretty short. We've got this we've got the most killer security team at Etsy. They're super smart and feel super, super lucky. We've got this developer, younger guy, super nice, but younger. I think he's still actually finishing his degree. And he was looking to see how, he was trying to fix a bug, and he needed to sort of gather some information about how this piece of code worked. And so what happened was, and it was a 8-line change. There were 8 lines, and he said, "All right, I think this looks good." And he looked. He said, "All right, here are these tests. I see these tests. These tests will catch it if it's no good." So, and he even asked the guy that sits next to him, who actually happens to be his manager. He says, "Hey, what do you think about this?" He's like, "Oh, it looks good." His manager's super smart too, pretty senior. He's been at Etsy for a long time. They're like, "Oh yeah, okay, so all right, yeah, this looks good." So, so they went to go deploy it, and there was another engineer with him, and we go to sort of essentially what is staging at Etsy, and test failed. And he's like, "Oh, well, this is no good. This is a test on checkout. It's a test on checkout." So checkout's kind of important, I think, pretty sure. So I don't know, man. This is really weird. Like, I didn't expect this. It's only 8 lines. What's the story? We should ask the experts. Let's ask the experts. So, Greg Horvath and Nassim, they're in Autobots, are excellent, killer automated testing expert guru, thought leaders. And he said, "What's the story?" And what they didn't know at the time was Greg and Nassim had this particular set of tests, or this particular test, like metaphorically on the operating table. What they had noticed, this was on a Monday, they had noticed on a Friday, was a completely unrelated piece of code went out and it sort of tickled this one particular test in such a way that it was flaky. Nothing worse than a flaky test, right? Screw flaky tests, jerk tests. So they're like, "Oh, we gotta fix this, we gotta fix this." So it had been flaky, like, it ran, it passed, it failed. It's like, "Oh yeah, we gotta, just fine." So they said, "All right, so yeah, we're working on this test." Oh, so it failed? Yeah, it's because it's flaky. We know it's flaky. It's actually fine. And the younger guy says, "Well, I've got a code review. I made sure that there was test coverage on it. I know what graphs to look at. They were like right there in front of him. I'm asking the folks who run the testing system. It looks awesome. Cool. Checkout goes down. So what should you do? Well, it turns out that not only was the test flaky, but it also, when in the areas that it wasn't flaky, it threw a different error, an error that would have signaled this. So now what do we have here? We've got the guys who totally know this testing shit, right? And they said it looked good, and his manager said it looked good. So what can we do? We can tell a story about this guy, this sort of younger guy who wasn't paying attention. We can tell a story about him being a little bit reckless because it's security and it's checkout. Checkout! That must have mean that the error was really bad. What a crazy, he just had faulty judgment. We could tell all these stories, but the fact of the matter is that would have happened to anyone, right? So, what's this story gets to us? The story gets to us is that the context that people are in when they both write a test, write an alert, or write a wiki page, or write the code matters. It also says that history matters. Greg had a history of, at least 24 hours at least 24 hours, it was over a weekend, knowing that this particular test was flaky. That's what led him to it made sense to him. No, this is probably what we're working on. So we're getting further and further away from science and hard engineering the more we talk, right? And we're talking more about the context people are in. And you're right that there's experience in there. But again, it matters. So, highly, I think we talked about this, so highly tested. Yeah, well.
So on that point, chemists test their testing plan, right, to calibrate your equipment.
Yeah.
Do we need to have meta tests?
I don't know. Would meta tests? Well, let me ask you this. How is chemistry different than software engineering? We could cargo cult it if you want. Because context is important. Can chemists roll back a reaction? Folks at 3 Mile Island didn't think so either. Were you going to say something?
Yeah, I was going to say, you talked about requirements and ideals and everything, but I think part of the agile kind of philosophy is that you can't really know, like you said, what your software has to do in your domain, and you build all these tests and you try and get good coverage, but then that's not really going to be fully covered. So your best tests are the ones you write to address failures. I mean, you have to expect that some things are going to fail.
Yeah.
And that's going to inform you about your domain and your software and your infrastructure going forward.
Right.
That's a teaching. So machine learning, so failure is part of our learning about the system we're building.
Absolutely. Absolutely. But I would argue so would success. In fact, I would say that, and I'm not the first to say this, Murphy's Law is wrong. The fact of the matter is that not everything that could go wrong does. In fact, if anything, it almost never does. It's again, these aren't my words either. The surprising thing is not that our code breaks. It's that our code works as often as it does. So, if we were to if we were to find the places, failures are just surprises that have a different name to them, right? And the actions and the sort of the decisions that we make in order to write this test, or put this graph into place, all come from the same part of our brain, right? The ones that end in failure and the ones that end in success. It's still the same thought process. It's still the same mechanism. And that's sort of more about the context. Highly tested, continuous deployment. I'm going to come around to, what is this part? You said it earlier. You mentioned, what's another way to gain confidence? Well, to release the new stuff to the internal company, right? What does that do? That reduces the surface area of failure, right? Which means that if it's going to break, at least the new stuff will break just for my company, like our customers, or that it might not break for them. Is that what you're getting at?
Yeah.
Yeah. I mean, this is sort of a reasonable thing to do. Well, you could take it even further and say that, well, I'm a developer and I could also put it into production and just have it turned on only for me as part of a whitelist. This is another way of doing things. And it is in production, which means he's using production systems. If it's in production, which is where it's supposed to land, then we can do it in such a way that we feel safe in doing so, by having confidence in our code, then we don't have to worry, we don't have to ask the question, is it failing because my dev environment is always a little bit weird? And it's a little bit different, it's different hardware. Like the version of Java is different, it might be, I mean, it could be. So like, how much did reducing that surface area 5 lines do you then? So that's one way. In that scenario, when we call that staff only or admin only here. We were talking earlier before we started about dark code. Who hasn't heard of the concept of dark code? Awesome. Okay. well, just I'll say it out loud. So dark code, there are varying ways of describing it. Historically, dark code is code whose execution path you want to receive the results of in its natural habitat, right? Which is production, which is AKA the only place that your business is going to get value from it. So, an example, the canonical example, is a number of back-end calls that your database, or that your application is going to. You're going to talk to a search cluster, you're talking to a database, talk to a caching server, or whatever, and you're just not entirely sure. Like you're pretty sure. Let's say you did a little bit of load testing, but you're not entirely confident that that the workload that's in production is going to be any good. So what could you do? You could say, all right, so you know what, for X amount of, at the beginning of my code, I'm just going to say pick a random number. If it's below this, if that number is below, pick a random number between 0 and 10. If it's below 5, then execute this code, go get all this data from these backend stuff, and then just whatever, don't do anything with it. Just throw it away. Just do reads, or you do writes or whatever. And that way, the user experience isn't at all affected. I mean, it might affect 5%. It might hurt, but if it hurts, it's only going to be 5%. You could even do it for, at that point, 0.1%. And so that way you can gain confidence in more sort of complex and or what feels risky. Feels risky. Not scientifically proven, not statistically, what feels risky as another way of gaining confidence. Oh, in the database, oh look, actually the database has handled it. Not so bad. You know what? Yeah, but I'm still not totally sure. Let's turn up to 10%. Let's turn up to, looks good, 50%. Rockin', 75%. That looks weird. All right, turn that off. Let's go figure out, memory leak, mumble. And your users didn't know. And it wasn't a scramble. So dark code is another way to gain confidence. Is this a test? To a certain extent. Just like a monitor, just like an alert is kind of a test. In that case also, if the case is that it's not about the back-end calls, but it's actually about user behavior. How are they going to sort of handle it? Well, let's say we do, like another, who's ever here used Google Labs in Gmail? Right. By the way, I highly, highly recommend I think it's like a 5-minute, or no, it's like a 30-second recall. So it doesn't send your message for 30 seconds, so you're like, oh no, I replied all. You should install it. So we have prototype groups. This is where we say our sellers and our members, hey, check this out, we got this new feature. We're not entirely sure that it's going to look like this. We're not entirely sure whether it's, it could totally break. So, but we've made it as safe as we can. So if you want to come check it out, jump in our little group here and let us know. Is it working? Is it slow? Is it what do you think? That means we're getting our users to test for us. Yes, we are. And we should be psyched about it because the people who are in those groups are so pumped to be doing that. Because they feel like they're in on it. So there's prototypes. And then there's just plain old percentage ramp-ups. Where the amount of confidence, yeah.
Jumping back a little bit to that.
Prototypes?
Is it about basically meeting the expectation, giving the expectation that it might break and potentially break?
Yeah.
Fail whale on Twitter, everyone now expects, well, it did, maybe not now, but some time ago, expected Twitter to fail sometime.
Right.
So is that related to that, or
I mean, except for the part where, well, in that case, was all of Twitter's members part of one big prototype group? I don't know if that actually was the intention.
About the story, but I'm not talking about this, like intent of failure, right? Or like deliberately
sure.
doing that.
But setting
expectations, however
yes.
they're set.
Yeah, absolutely. So, but I want to point that out is that this is a it is a valid option that's not certainly going to work for everybody. You can't send a man to Mars in a prototype group, for example.
Unless they're okay with that.
Unless they're okay with that. But it is about gaining confidence, right? Who said software development can only be done where running tests before it launches to every user all at once should be the way to gain confidence? Who said that? No one says that. It's not a law. The only reason why we did that for ship software is because it was damn expensive. If you worked at AOL to recall all of those CDs on people's front steps, that's expensive. So let's, when you're printing CD-ROMs or putting together punch cards, that's kind of expensive. So we're gonna do what we believe is proportional testing in the ways that we have confidence. There's another, I don't believe it's too much of a stretch, a friend of mine, Andrew Schaefer, so there's another domain that has been doing continuous deployment for a long time and been doing percentage ramp-ups. The pharmaceutical industry. Small and frequent means clinical trials. Okay? So we're not really inventing anything. But what we are doing is making a statement about what our values are surrounding risk. If we believe that the risk is too large, then we're going to have an appropriate amount of what we believe to be an appropriate amount of stuff that we do to gain confidence and to gain confidence. What's that? Totally. I mean, absolutely.
It's kind of like, pre-staging testing. I mean,
you're totally right. You're totally right. But what I'm saying is that in that case, they made use of prototype groups. In that case, but a drug doesn't get ingested by a human for the first time, at least in most of the countries I'm aware of, on the same day for everyone.
yeah.
Right. That's the point what I'm saying, and that's where I'm saying is that there is an appropriate amount. What preparation we go to doesn't just say something about how we view risk. It also says how much confidence we have in our ability to undeploy, our ability to respond if there is an issue. So again, there's nothing. It isn't. What I think continuous deployment really is about our ability to call into question what are other ways besides test the shit out of it before you do anything to gain confidence.
Do you think that confidence building as a perception is a different process for people who have the luxury of building a new product from scratch versus trying to fix something that's been broken?
That's a good question.
It's a loaded word, confidence. I was
Yeah.
wondering if it's the same thing for
Yeah.
the project.
No, so I'll repeat the question. The question is, if given two scenarios, somebody who's building something brand new from scratch, and versus somebody who's been, attempting to fix something that has had history there, then I think the answer is yes, because history does matter. What we've used to, in operations, we say that the architectures of tomorrow are informed by the incredibly traumatic outages of yesterday, right? How many times you want to say when you go to a new company and they say, oh yeah, we write our code in whatever, mention any language. We write our code in everything, and then you remember back to when you worked at that other company that also wrote in that language, and it sucked. You hated it, and you're like, oh, I can't stand Perl. Oh no, that's no good. But you don't have any. You had a terrible time, but there's extremely successful sites that run Perl right now. If I'm not mistaken, I wouldn't say decent, but there's a non-zero amount of Amazon that runs Perl right now. So what does that mean? It means that we do bring our experience, we bring our perceptions, and that's what informs the decision we make. If we pretend that what we're doing is science, we're so fucking full of shit. We're not doing science. We make decisions based on our feelings more often than we do statistical significance. The second that we understand that, then it becomes a lot clearer in various ways we get confidence. Can we get confidence by only using staff only? No. Dark? No. No alerts? No. Testing? No. Security calls this defense in depth, right? The security world talks about vulnerabilities and attack vectors, and they don't believe that there is a single way that you become secure. And in the same way, there's no reason why we should place all of our bets on software being safe and functional and performant in one particular basket. So, fully automated. Who said fully automated? Awesome. What if you're not fully automated?
Mostly automated.
Mostly automated. Except for the places where we can't figure out how to automate it, and or it happens so infrequent that it wouldn't be economical to do it.
Well,
Who's going to make decisions? Not the computer.
Or there's too much risk in automating it.
Or there's too much risk in automating it. Right. Why would there be, talk more about that. Why would there be risk in automating it? I mean, because look, you got rid of the human, right? Like, you don't have the human there. So, I mean, when I see fully automated, I see, let's get rid of the dirty, dumb human who fat fingers stuff. But why would there be a lot of risk in fully automating something?
I'm sure that you guys have processes that aren't fully automated. Like,
We certainly do.
yeah, I have a whole ton of them.
Yeah, absolutely. Probably more than you would think. And we like it like that. Some people say that because what Brad Fitz wrote a handful of years ago is that at IMVU is that that continuous deployment means that every commit, as soon as you commit, it goes to production automatically. Leave it training. Right? Is that it? No. /star, not star. I'm not going to let you go. Tell me more about why would it be risky to automate something?
Like database migrations, for example. Maybe,
Yeah.
Yeah. Maybe you're changing like a lot of stuff in the database. You want to have like 5 people sitting around watching that. And
Yeah.
one person.
Yeah. That's expensive, right? I bet you Amazon wouldn't do that. They got drones.
One risk with fully automating something is that, you know, when you write your test suite, you're testing specific things. But of course, you know, like you were saying earlier, there always is something that you didn't think of. So let's say some of your tests generate graphs, and, you know, according to the test, everything is cool, but if a human looks at it and sees some graph doing some weird thing that there's not a test for, well then that's why you wouldn't want it.
Exactly.
It basically trades like halo coverage for repeatability. So you get narrower, more accurate testing, or more consistent testing.
Right. That's a really good way of saying it. Consistent. It's going to do what it's told. You have a higher confidence that it's going to do what it's told, which means that there's less variability. You said, I'm going to test this for divide by 0, and that's what it's going to do. It's not likely sometime next week it's going to say, you know what, I'm just going to start testing it for uppercase letters, right? Repeatability. But,
when the shit hits the fan.
what's that?
When the shit hits the fan.
When the shit hits the fan, right?
One case that it gets talked about is failover, database failover
Yeah.
application, or if they do have automated failover, they make sure that they don't have automated failback.
Yeah. Yeah, we don't do any of that. Screw that. I don't know whether it's not. I don't know actually whether it would feel economical to solve that problem. So yes. So automation is. I'm not arguing against automation, but expecting that there comes with it inherent risks. Some of the stuff that we talked about before is still there. Also, when you automate something, it's pretty easy to actually to write stuff that does a lot of things very fast, right? So fast that our ability to monitor them as humans can get, like, we're pretty damn slow. We're really good at making things go fast. And what was the quote is that you can certainly, with automation, you can make the site go down even faster. And also not be entirely clear why, right? Because automation can be very opaque, especially if you have automation that interacts with other automation. We hear a lot about this in configuration management sorts of crowds. You'll hear about, self-healing systems or self-repairing stuff, event handlers that will kick off a number of rules engines, if then that, and that sort of thing. IMV called it cluster immunity, right? Which sounds great and all, until the shit hits the fan, in which case that's the one time when you do need to be able to catch up, and you do need to be able to understand what's going on. But remember, you automated yourself out of the loop. So there's a trade-off to be made there. There is something where if you haven't, I'm going to suggest a whitekeeper. I am now in the habit of doing this almost every day, much to the dismay of all my coworkers. 1984, a woman named Lisanne Bainbridge from Cambridge wrote a paper called The Ironies of Automation. And later on, a couple of other smart folks sort of expanded on her a bit. And part of the irony of automation surrounded this idea of the leftover principle. It's the approach that people make, again, like in the name of repeatability, in the name of certainty, or at least the hope of certainty, that you have this leftover principle, which is to say, I'll take all of the easy things, and then I'll automate them. That'll make things easier for the human. Except there's a problem. And usually people say, well, if I automate things, then it'll free me up to do more interesting things. And if we dig a little deeper, what we're saying is, add this to what we were talking about earlier, which I think we agree on, is that we automate all of the things that we know how to automate. We don't automate the things that we can't imagine how to automate. Which means actually, we're not making things better, easier for the human. We're actually giving them the hard things to do and leaving the computer to do the easy things. In which case, opaqueness, figuring things out, is now in the hands of so there's a paradox here. Is now in the hands of the human, the unreliable, irrational, non-repeatable being. We just gave him all of the hard stuff. So that's what the irony of automation is. And it's a great paper. It's, like I said, I think it's from the 80s. It's either 1978 or 1984, so they're certainly dated. I think she mentions cathode ray tubes. But it is very, while it is dated, it's super, super, appropriate for the times. All right. So, what else? How long am I supposed to talk for? I'm not kidding. I would just continue to go. How long did we say what I was going to talk for?
About an hour. Yeah, a few more minutes.
Okay, all right.
Is the leftover principle less of a concern, like when a practitioner is writing tools for themselves or for a very small team?
Yeah, that's a really good question. And the world that Bainbridge lived in was not one that we live in today, and that's a stark difference. A lot of the automation that we are all in this room familiar with, we are also the users of this automation, right? Not that, well, for the most part. Or we sit or work very closely with the people who do use the automation. And in the case of open source software, it makes it a little bit easier to reason about because you can look at it. So does the leftover principle. I think almost certainly, if you were to ask somebody about why to use automation, they would probably repeat what is almost certainly the leftover principle. Without it not being entirely clear about the paradox inherent within. A second, more follow-on of the leftover principle is, I guess what's known in human factors is the Fitts list, named after Paul Fitts, came from aviation, or there's some folks call it the MABA list, which is the entirely dated, gendered, men are better at, machines are better at list. And this also is a falsehood, which is to say, in this case, it's humans, in order to bring it up to be like truly modern. Humans are better at these lists of things. They're better at induction, making decisions and taking actions based on missing or faulty information. They are incredibly good at visual perception, right? What are other things? Just making judgments. Computers are good at deduction, right? Rote calculation. They're good at repeatability, and so forth and so forth. We have these two lists. I was like, oh, this is what I'll do. I'll just make sure that I'll just do all. Every time I come across these things, I'll give it some shade. Anytime I ever have to do these things, I won't automate that stuff. And that's fine and all, except for the part is, there's no very few activities in modern life only fit within those buckets. Either the computer does something and then the human has to do something with it, and then back and forth. It is a cooperative, it is a relationship, not you do everything and then you do this other thing. If you were in that world, then what you could say was that was a very anti-DevOps, very siloed scenario. So yeah, but I mean, I think that when we reach for automation, because that's our hammer, right? At least as software engineers, of any domain, that is our hammer. That's the thing that we do. The solution is we write code. Just note that all pieces of code is automation to some extent. I do believe that it actually matters. If air traffic controllers were also the ones who wrote the software that they use, the world may look different. I don't know exactly what that would look like, but I'm willing to bet that it would probably look different. Or if the pilots wrote the software for autopilot. Right? So, any other questions around this rambling madman that I am?
So do you think that with automation, the probability of error and cost of error also higher? Or maybe not probability, but the cost of error is just higher and complexity, because of complexity.
So much. So much in there. I don't know. What do you think?
Well, I believe manual or simple software that is understandable by humans are easier to write, while software that requires a lot of abstraction and a lot of kind of thinking from all perspectives is harder to write. And automation is definitely in that field where you need to take a lot into account when you write that software. So one mistake can actually cost a lot, and having that relying on that to replace human actually is quite dangerous without, I don't know, making sure that it actually works.
Possibly. I think that once there's a language scenario that can bite us here. At Etsy, we get a lot of tests. How many tests do we have? A lot or a little? A lot.
Yeah,
A lot.
Like 15, 20,000.
15 or 20,000.
Is that list outdated?
But well, it was outdated as soon as it came out of his mouth. It's completely outdated. We now probably have 15,001 and 2 and 3. At Etsy, we deploy to production manually. We've got the button is green, it says deploy on it, and it's on a web page, and when you want to deploy to production, you press it. Could we say that's manual? I don't know. The human triggers it. The human doesn't package up all the bytes on floppies and drive down to the data center. Is rsync automation? Look, it's a computer, so it's all automated. Some things are triggered. You could say some things are triggered by the humans. Some things are not triggered by humans. But what happens in between is where the complexity lies. The complexity doesn't just sit in the code. We don't get to like wash our hands and say like, it's complex because of the code. No, it's about our relationship with the code, right? We just talked about a number of, I didn't talk about anything that's technical here. I didn't write one bit of code on these whiteboards because there's nothing technical about confidence and how we choose them. So, does it cost more? I don't know. If it did, what can we do with that information? I would say that every decision that we make or action we take in the gig on getting like this software to do this thing so that the business can do the work and make money or the world a better place or whatever it's supposed to do, or kill people, whatever it's supposed to do. Then at every place we've got this tension between being efficient and being thorough. And if we believe that the cost is going to be really high, we may err on the side of being thorough. we think that the cost of getting to market is going to be more than the cost of failure once we get there, then we're going to be more efficient. It's not that there's like a one true way of getting at that. I would say, is 15,000 tests enough? Is 14,000 enough? Is 16,000 enough? I don't know. I don't know what the formula is. I don't think that we have a formula. So I think that the answer, the long answer, is that it's context sensitive. The actionable thing that we can do is to call out when we're explicit about being thorough or efficient, right? We see this all the time. This is what's known as technical debt. You come across a piece of code, there's a comment in the code, and it says something like, must remember to take this out later. Right? So, what can we ask when we come upon that? Who has written that comment before? Right. I would say you probably suck as an engineer if you haven't. Just kidding. No, you're terrible. Because then you're at least a little bit more explicit in that I have chosen to do this in a way that is different than I could also imagine it. We then get to ask questions about that. Why do we usually do it? Well, because we probably committed to a launch date, or we committed to doing something else that prevented us from doing it the right way the first time. How often would we find bugs in that code preceded by that versus code that's not preceded by that comment? I don't know. But there is something worth calling out that we were explicit. Like, I have an awareness that we could do this differently, but the cost of doing so, whether it's a financial cost or a cognitive cost or a time estimate cost or anything like that, is not high enough to write it. You had a question?
I did have a question. Just stepping back a little bit. Let's say you wanted to move towards a model of continuous deployment. Let's say, hypothetically speaking, you were on semi-scheduled releases and it was a very painful and inefficient process, hypothetically speaking.
Mm-hmm. Hypothetically speaking.
Yeah, yeah. Oh, and we have a lot of sites, right? And by the way, they are all built in Perl. So,
awesome.
But let's say you wanted to move towards a model of continuous deployment. Mm-hmm. So, what would be? Because I had thought that what we were missing was the lack of fully automated testing. We just don't have that right now. But what I'm hearing is that that's not the case. That even if we were to have that in place, that like, what's the low-hanging fruit that you need to have in place if you want to move towards that? And then part two is, how do you know if it's the right model for you?
That's a really long question, but it's a really good question. So that leads me to more questions for you. But before I get there, I would say what would be the problem that you're looking to solve? Is the problem that you want to solve the fact that deployments are painful?
For everyone.
Continuous deployment does not have to be the only way that you do that. I would ask about why it's painful. If you believe it's technically painful, then there are ways that you could sort of you could ask more questions about why technically it's painful. Almost certainly as part of that conversation that you might have with coworkers, what's going to show up are non-hard science backed by statistics bits that we talked about before. You're going to come up with philosophical approaches, philosophical thoughts on how software should be deployed given your current scenario. So I can tell you how it works here at Etsy. I will tell you that a lot of the stuff that we're talking about is only there's no single one thing. There are a number of things that companies who are successful at continuous deployment do that are common through them, but I don't think there's any one. You can't just say, no matter what you do, you got to do this. You could actually have a terrible deployment process. It could be manual, but you could be continuous deployment, and your deployment could be super painless. When I first got at Etsy, the testing infrastructure was up in Amazon Web Services. It ran on like clusters of build bots, and it just creeped under the weight of what we just simply asked too much from it for too long. So we did what we knew we should have done, and we nuked every test. So this is before Greg and his crack Navy SEAL team came, but for a decent amount of time, we just simply didn't have any tests. There were no tests. When I worked at Flickr before Etsy, I don't even think we didn't have any tests. We had 0. We deployed 10 times a day. We had 0 tests. There was no Hudson. There was no, towards the end we had some tests, but we didn't have what we have here at Etsy.
You have manual people clicking around a lot?
Yeah, developers.
Oh.
Right? Product people. We had all of these. We had the dark code, we had staff, we had ramp-ups. So again, like I could say, you could have the most killer rocket automated testing. You could have the most expert people who in the domain about how to write tests and how to write them efficiently and how to make a testing infrastructure run so its tests run super fast and code coverage and blah blah blah, and still suck at it. So I don't want to give you like a really crap answer, which is it depends. Even though that's actually what I'm giving you. I can tell you a couple of things that I feel are reasonably worth looking into, and that is bringing developers touching production as often as possible, and making sure that the people who write the code are responsible for it in production once it's there. My friend Mike Nygaard wrote this awesome book called Release It. If you haven't read it, you're totally missing out. It's one of the best books. It's essentially about operations. I don't even know if he knew it at the time, but he was writing about operations from a software developer background. And he said something super smart, which is that writing software and preparing for only calling the release of the code into production, for a developer, that's like preparing for the birth of a baby and paying no attention to the idea that you have to raise it and bring it home. And it's hard to argue with. So getting developers as close to production, here at Etsy, it is that you wrote the code. Look, you seemed real smart in the interview. Why don't you have the stones to deploy it yourself? So then, when you do that, you don't get crazy cowboys. Woo! Deploy, deploy, deploy! I don't care. Demand by 0. Like, you don't get that. What you get is people rising to the occasion to look for places, maybe places that operations people and QA and designers and many other people, even other software developers, they know what it makes for their code. They know what they want their code to do. They are the author. They are the expert in their code. So they ought to be the ones to be able to dictate what of the ways that they can feel confident in it. So that's what I would say. There's a couple of ways of doing this. I've heard some companies having let's just get one developer team to start this idea. We should rename the team to like a DevOps team or something like that. I don't subscribe to that notion. We were seeing Daniel said, how long will it take, how long will it be before I say the word DevOps in this talk? It's just a word we never say. See, it's like it feels weird to say it. It's like, it feels weird to like peeing on the floor in a conference room. Like that's how weird it feels to say, well, we're going to DevOps this, right? Like, or something along those lines. I personally would do what we did here, which is cold turkey. All the developers deploy. And when you do that, here there are a number of, speaking of monitoring, there are a number of teams here at Etsy, software development teams, who they now have their own on-call alerting schedules. They are writing, there are alerts, Nagios alerts that are written by developers that operations haven't even seen. They don't even page operations because there is an ownership. I'm responsible for this code. If it's awesome, I want to be, by deploying this, I'm signing my name to the code. And in a not so, and that kind of goes well around here because, it's kind of our business is to sort of empower what people feel passionate about making to sell to other people, right? We've got, these are handmade sort of roly tables over here. Sellers stamp their name because they're psyched. My name is John Smith. I made this mahogany table. It's awesome. My name is Greg Horvath. I wrote this code. If it explodes, come at me because I want to know why it broke so I can figure out what to do the next time.
How do you manage transitioning that to people?
What's that?
How do you manage transitioning that to people?
We make them deploy on their first day.
Well, old features that have old monitors that with one person and that person no longer is responsible for those things. Fire, quit, whatever.
You mean like you're getting at like code ownership?
Well, if you're talking about, I wrote this.
Yeah.
Now I'm gone. Now who owns it?
Well, you mean like gone as in a different team or not at the company anymore?
Either.
So in the case that you're in, and this does happen, right? If you're just in a different team, and that feature is still like providing value to the business, then you probably told and walked somebody else through that code. Regardless, it's still in the same repo. Anybody can read and change it anyway. There's no defined lines between there's no don't touch my shit. But once you get it so that people can whatever do the GitHub thing and submit pull requests, I'm going to help you out here. Then that's okay. It's messy, which makes it awesome. One more question. I didn't answer your question very well, but I'll do 30 more seconds, and then we take one more question. Developers deploy. Operations gets to a place where they're psyched about it. Where they're psyched about developers deploying. People have asked me in the past, like, so operations at Etsy doesn't handle releases? And I say no. And people have said, then what do they do? And I was like, you know what? When an ops organization doesn't have releases as part of their responsibilities, you would be amazed how much proactive work gets. Believe me, they are the busiest. They are some of the busiest, innovative groups that I've certainly ever been sort of a part of. And yeah, I guess that those two things is probably a good start. Other people will say one button deploy. You'd probably be in good shape if you did that as well.
What's one button deploy?
It's by having a button on a web page that says deploy, and it deploys.
Or we had a Cuba
to production. What?
We had Hubot. We had
A Hubot.
Hubot, yeah. We had a script listening. It's in your chat thing. You Hubot
Yeah,
it,
yeah.
deploy now.
Yep.
It runs a script and boom, your website.
There you go. That. So you want to have one, a bit, like, let's say there's a number of steps. Write a bunch of verbose logs, but make it so that you've got one trigger that makes the thing go. Okay, last question. No, you had your hand up.
So, it seems like this basic problem goes down to risk assessment and then cost of risk versus cost of implementation for automation or whatever, what have you from that entire list of everything. But how do you overcome, I mean, there's all this research recently about optimism bias and all that, especially among developers, scientists, everybody that does this kind of work.
Sure.
How do you develop confidence in your risk assessment?
How do you develop confidence in your risk assessment? So, first let me take a quick stab at the supporting premise. You're right, there is lots of research. Optimism bias is not even close to being the only cognitive bias that we fall prey to. Right? And they absolutely influence how we view risk, and how we oversimplify and reduce the actions, especially when we're trying to describe the past. Reduce our what went into a particular decision or a particular action, whether it made sense or not. Wait, what was the second part of your question?
How do you build confidence
Oh,
in
yeah.
the risk assessment system?
Right. So essentially what you're asking is,
How do you make sure that you're accurately figuring out, I need to automate this because it's risky, and you're not doing things that you're not accidentally doing things you shouldn't be doing.
Right.
Not doing things you should be.
So there's a couple of thoughts there, and a lot of it essentially comes down to learning how to learn. And we didn't talk about learning, but essentially what it gets at experience, it gets at path dependency, it gets at history matters. So if risk is informed by our history and our imagination, then and if we believe that the limits that we've set for ourselves of risky versus not risky change over time, meaning if we feel as though we're going to be more successful if we have a longer history of success, right? Then there is a danger that we are becoming, wait for it, complacent. Is this what you were getting at?
Yeah.
How do we have confidence that our risk assessments are up to date? Essentially, we can't. Remaining sensitive to the possibility of failure, even in the wake of a huge amount of success, is a thing, and it doesn't require the internet to underscore this. Does anybody know a good example? Dan?
We talked about at the DevOps conference, with the Velocity conference, they have Richard Cook's description of when you become complacent, you move closer to the boundary of failure.
Right. It's an excellent talk. What's that?
Black swan theory.
Sort of. Almost black swan theory. But not certainly unrelated. Black swan gets at the idea of fundamental surprises. What Richard Cook spoke about at Velocity, if you haven't seen it, was normalization of deviance. The example here is that how confident should we be about launching this shuttle when it's a little bit colder out? It hasn't been this cold, but we've got confidence from a number of other. Also, we've done this 23 times. In that same talk, Richard said that most thoughts on safety, including software safety, can be traced back to, we owe it all to 3 Mile Island. I would say this normalization of deviance, this came from the Challenger and later the Columbia disaster. And it's still, I think, very, very appropriate. We still have, there's yet another paper, see, you've got me now twice doing it, by 2 guys named Starbuck and Millikan. And they said they have 3, you could break down 3 probabilities of future success and failures, in 3 theories. And the first one is your path, your history doesn't matter, and there's no way that you can predict whether you're going to be successful or have a failure. The second one is a history of success may make you more feel more confident about having a subsequent success and less confident about having a subsequent failure, right? And then the third one is the flip, right? Which is if you've been successful, the longer you've been successful, you're waiting for the other shoe to drop. The longer you've been successful, the more likely you are going to have as a failure the next time. The notion that normalization of deviance is to, 1, accept that you're not going to know where the boundary is until you hit it. And 2, that it's if you leave out the conversation or dialogue about how you normalize your work. Richard did a fucking awesome job about telling a story if you've ever had a toddler, and he tells a story of like, okay, so you're in the kitchen, you're cooking on the stove or whatever, and the toddler comes in, you know, it's this hot stove and there's grease and whatever, and the toddler says, okay, listen, don't come in the kitchen, I'm like cooking here, I don't want you to get burned, okay, right? And he says, don't cross this threshold, right? Stay in the living room, don't come in the kitchen. The linoleum starts here. And what is the first thing the toddler does? Is go straight up to the line, right? And then if you turn back, they go back, and then you turn around, and they're going to come forward, and then you might jump over the line. Nothing happened. You might go back, right? And then they'll come forward, and the next thing you know, they're standing right next to you. This is normalization of deviance. So we deploy 30 to 40 times a day. Would 75 be okay? What about 150? Would this work with 500 developers instead of 150? I don't know. I think that one thing that is worthwhile is to continually ask the question whether or not we are up, whether we think we are up against a boundary or not. And just note that this normalization of deviance is like it's a thing. It's not unrelated to what's known as risk homeostasis. This idea that with every improvement we make to any system, no matter what kind of system it is, we're going to erode a boundary. Like we're not going to be, say we got a system and let's just take regular capacity planning, right? We take advantage of Moore's law and replace a bunch of servers with a bunch of faster ones. Now, are we going to just reap the benefit of having that, or will we run them hotter? Does ABS, anti-lock brakes, cause people to go slower, or stay the same, or do they go faster? They go faster. So, I don't know the answer to the question. I think probably the only way that I like to think about it, especially here at Etsy, is to keep the dialogue alive whenever we're making decisions. So, sorry, I'm getting kicked out. Thanks for humoring me.